Standards bodies don't just set technical specifications, they also drive greater understanding of the topics in enterprise technology like storage and AI. This episode of Utilizing Tech, brought to you by Solidigm, features Dr. Jay Metz, chair of SNIA and the Ultra Ethernet Consortium and technical director of AMD, talking about how we can spread standards and ideas around the industry. Welcome to Utilizing Tech, the podcast about emerging technology from Tech Field Day, part of the Futurum Group. This season is presented by Solidigm and focuses on advanced topics like AI at the edge and related technologies. I'm your host, Stephen Foskett, organizer of the Tech Field Day event series, and joining me today from Solidigm as my co-host is my old friend Scott Shadley. Welcome, Scott.
Hey, Stephen, good to see you again. I know we recently saw you in person, actually, at a recent field day event. That was awesome. Great to be here again.
Yeah, it's good to see you as well. And as I said, you and I go way back. One of the areas that we've both focused on for a long, long time is storage. And those of you outside the storage industry may not know it, but there's actually a really nice community in storage. A great group of people who love to get together at events. For example, the Storage Developer Conference is one of my favorite nerd fests. FMS, there was the old storage conferences and so on. And one of the coolest things about that is sort of the cross pollination that happens when you learn about what other companies and other people are working on, and you try to bring that into your world.
Yeah, absolutely. I mean, that's a perfect example of that is I have chosen my attire appropriately as I now sit on the board of directors of said one of those groups, SNIA. And it's been an interesting way to utilize, to your point, what's going on in the market around, all of us working to drive innovation forward. But we all know that we can't just do it as a one off. We can't be unique or independent in certain ways and aspects of that. And so being able to tie all that together and bring it in as a conglomerate of people and companies to present to our customer base makes the existence of all these technologies more possible.
Yeah, it's been really great having, I think people, when they think about standards bodies, they think about the technical aspect of standards bodies rather than the sort of evangelical and spreading the gospel aspect of standards bodies. SNIA is one of the companies, or one of the organizations, I'm sorry, that is really, I think, spreading the gospel of storage far and wide. It's not about, totally looking inward at, how can we make storage better. It's about how can we bring storage to the world. And that's why we have brought our old friend from who happens to know a thing or two about SNIA, Dr. Jay Metz, to join us here on the podcast. Welcome to the show, Jay.
Thank you very much. Very happy to be here. Thank you.
So tell us a little bit about yourself.
Well, I am a technical director for advanced storage and networking strategy for the data center group inside of AMD. And I am also, as you said, I'm the chair of SNIA, have been for about 5 years now. And I'm also the chair of the Ultra Ethernet Consortium. So I've got kind of hands and feet in both areas of the networking and the storage networking and so on and so forth. So that's what I do. That and wear hats.
Yeah, I was going to say, and of course, he's wearing the traditional J Metz hat attire that is known for far and wide. It is Stephen mentioned you go to an SDC event, and if you see Jay without his hat, you don't know who he is. So
Well, if I
it's been
take off
very
the hat,
entertaining.
it's a being incognito. I would never ever make fun of Superman, for taking off his glasses because I take off the hat and people just don't know I'm there. It's a
It's
fascinating event.
And now speaking of not knowing that you're there, that's one of the things that people take advantage of, if you will, as far as what this conversation is about, which is how we participate in these standards and these different consortiums and what it's really doing for the market and for our customers. And a lot of the time, those folks don't really see what this behind the scenes does. So to Stephen's point, the evangelical part of it or the communication piece of it is something that you and I have spent a lot of time doing together within SNIA, and now you as part of UEC as well. So.
Yeah, and it was always kind of interesting because, from the outside looking in, you think that this is just this one big monolithic entity that's kind of solving a particular problem, but it winds up being much more involved than that with different perspectives and different attitudes and different thoughts and ideas and creative venues, but it winds up being particularly interest for those of us who get involved in this sort of stuff because there's always a new problem that has to be solved. Nothing is ever really finished. So we get some pretty nuanced approaches to solving problems that get both big and very small in different areas.
That's a good kind of summary of storage. One of the things that makes storage interesting is the fact that it is very big and very small and very fast and very slow and very high powered and very low powered. I mean, storage is a lot of things,
It is.
and you and I, and well, all three of us are really have been discussing all of these aspects of this technology for so long, and yet I think again, there's not as much understanding of the nuances of storage, but that's changing now that we're starting to have greater and greater demands. I mean, uh, AI drives greater use or greater collection of data. It requires data to make it work. AI based applications are very data driven applications, and data collection means storage. It drives storage capacity, it drives storage performance, it drives bandwidth, it drives connectivity and networking and IO. And these are all things that groups like SNIA and the Ultra Ethernet Consortium are trying to evolve, right? I mean, have you noticed, and I'm going to ask you a leading question here, have you noticed that these things are ever more in demand in the modern world? What we've been doing in storage is suddenly really important.
Well, I think the short answer is yes, of course. The longer answer is a little bit more involved because the three of us and those who are storage oriented people, we've got a certain intuition when it comes to what we mean when we use the term. For those that are maybe software oriented or compute oriented or hardware oriented, they may not see storage the way that we do intuitively, right? They may see it as capacity inside of a drive or a hard drive in and of itself. That is storage after all. But the real element that we think about when we talk about this is that it's not just about how it's stored. It's about how you get it back. How do you move it? How do you preserve it? How do you make sure that it is there when you need it, at the right place where you need it? How do you make sure it is the exact thing that you thought you were going to get? Um, and so what winds up happening is that what we consider to be storage, other people would call memory. Other people would call networking. Other people would call software. Other people would call, backups or archiving. Other people might actually look at it and say, it's management, right? So all of these things are depending upon how you take the diamond and you look at the different facets, and you could see storage reflected back at you at any given point in time. But, what I think we try to do in SNIA and what we're trying to do in UEC and some of the other organizations that we work with is that we're trying to say, look, if you say that you do this or you need this kind of or that kind of bandwidth or you need this kind of latency, what do you need it for? Well, you need it for getting data from one place to another place. Well, what does that entail? And the further down that rabbit hole you go, the further there is to go. It's sort of like saying, what is the length of the English coastline? As you start to drill down until the beaches and the actual individual grains of sand, you start to realize that it is an ever increasing fractal distance of information that you're going to have to try to consume. Storage is the same way. If you want to talk about moving a bit from here to there, what does that actually mean? Does that mean you have to go through buses? Does it mean you have to go through buffers and caches and NAND or high bandwidth memory? What does it actually mean? What are the channels that you use? What are the networks that you use? All these makes a difference, and it makes a difference at a really small level, and it makes a difference at a really big level. So, for instance, I know recently you had a conversation with Gary Greider. He deals with really big systems, right? At now, really enormous systems. I mean, he's got petabytes of RAM, for example. And then at the same time, you've got these AI models that are starting to approach the trillions of parameters. And the average layperson doesn't understand what that means in terms of having the material to be able to do this. If I've got a 1 trillion parameter large language model, for example, I need around 32 terabytes of RAM just to be able to hold it, right? Well, no processor has 32 terabytes of RAM, which means you've got to be able to have a lot of processors together working together as one unit. Well, how do you do that? The data has to move from one place to the other, and you create little tricks, right? You create parallelism in little tricks. That means that I can have things going at the same time. But what do you do when you do that? Well, you change the nature of the data movement. It's no longer big pieces of data moved all at once. It's now big pieces of data moved all at once and little pieces of data moved all at once to let everybody know where the big pieces of data are. So you've got you're moving, the needle in a number of different areas at the same time just by small little tweaks in what you're trying to accomplish. And storage has to embrace all of it. And so that's why what we do inside of SNIA is so interesting because we have to do all of it.
Yeah, and if you look at it from that perspective, I find one of the unique pieces of that is, like, look at the history of Solidigm and where the markets come from. We had the introduction of EDSFF and the small form factor, which is now SFF within SNIA. Its whole purpose is to help with connectivity, what the box looks like, and things like that. And we've got new systems and solutions that are being utilized by even the fastest AI clusters now. They're using a unique form factor designed and developed out of something like SNIA and led by a bunch of these different companies paying attention to what you're talking about. I have a very dear friend in the virtualization world, and I think I may have not used this previously, but he still talks about storage as chips. And I mean, we're talking SSDs that sit at 64 terabytes, and to him, it's still just a chip because he's not a hardware guy. And so that's where we, as these groups of people who really know what he's talking about, can help evolve that ecosystem without him really having to change his definition, but just solve his problem.
Well, I don't want to cause any face palming, but I think a lot of people still think of storage as disks or maybe even as tape. And of course, they're still relevant technologies. And I think that if you ask somebody in the know about storage, they will absolutely stand up for disk and tape, but they will also say, you check out what we're doing here, you know?
And as well they should, right? Because the thing is, like I said at the very beginning, we understand and intuit what it actually means, right? And so, but when I talk to the people at UEC, for example, or I go across the aisle to OCP, or if I talk to people at the Linux Foundation, I have to choose my words more carefully because there's the shortcut of saying storage doesn't exist with them, right? They're, incredibly intelligent people, but coming from a different perspective. So it's really important that we allow ourselves the luxury of learning how to communicate the proper terms in a way that's going to be received correctly, right? So when I want to talk about the data for AI, or if I want to talk about the data for HPC, that gives me the ability to have a level common ground of when I'm talking topologies and networks, or if I'm talking about bit error rates on the physical level, or if I'm talking about in-network collectives at the software level, because by being able to redefine the question, you have a lingua franca that you can use to be able to associate what they want with what you can provide and vice versa.
Yeah, and you actually bring up a very interesting comment about the fact that the cross pollination, right? So I sit on SNIA board alongside yourself, but I also participate in NVMe and a few of the other things like OCP, whatnot. And not only do you have to choose the moniker, the terms you use, but you also have to be careful about overshare and undershare and stuff because there's all these nuances. Just like you have NDAs between companies, you have relationships between consortiums, and until something's officially official, you actually have some unique aspects of how managing all of this stuff comes into play, and being able to address that and drive across those barriers and driving solutions is kind of a unique aspect of what we get to do from that side of our day job, if you will.
Yeah, and I think it's absolutely critical. I mean, last month we had a joint session between UEC and SNIA, right? We had a face to face between the two different organizations. We did technical symposia individually, and then in the evenings we had birds of a feather where we could kind of combine and work. And then of course we had the regional SDC, where the materials should be available online soon if they're not already. And the whole purpose here is to make sure that the work that's being done can be extended into other areas so that people don't have to reinvent that wheel. UEC is one of those places in particular that is specifically going to hurt in the data area if it's not careful, right? And this is not necessarily just a SNIA solution either, but the SNIA group needs to be able to understand the proper, framework under which the work that they're doing is. And so mixing the two initiatives together is really important. If I want to, so for example, in AI, we have multiple network types. We've got a front end network, which is your general purpose network, and that's where most of the storage lives. Then you have a purpose for AI, right? You have a purpose built network for AI, and that's what we call a back end network. It's like the 32, terabytes of RAM that you need in order to get a system to work for model. But since you need the data on one network, but the data exists on the other network, you want to make sure that you have the best and most efficient ways of transferring the data. Or in the future, you want to have the data on the network that's doing the processing, which right now it isn't. So that's a fundamental aspect of AI that most don't even realize. Right? They don't realize that the data isn't even where the processors are. It just doesn't exist. So you have to go through all kinds of unnatural acts to get the data into the proper network so that the GPUs and the TPUs and the accelerators can actually process it. And then if you're doing a lot of that movement, it makes sense that the organizations that are focusing on the AI network and the organizations that are doing the storage talk. And that's the whole reason why we're doing what we're doing.
Yeah, you bring up a that's a very interesting, and to your point, as I mentioned, we recently saw Stephen in person, and one of the aspects of the presentation that we brought forward was working with a partner to highlight how we can leverage storage to actively replace aspects of the memory required to drive some of those language models. And there's trade-offs. Do I spend a fortune on the RAM to add and use my storage and accept a little bit of those trade-offs and things like that? But those are things that these organizations can't take the time to think about if they're busy thinking about that true back end that we're driving with the consortiums and the work that we're doing to get data from here to there, whether it's edge in AI at the edge or AI in the data center or rack to rack, all that kind of stuff plays a very big part of what we kind of drive with all these different efforts that we're doing.
Well, I've always been a big fan of one plus one equals three. And I've used that phrase before. But if you look at a particular technology like we've got inside of SNIA, and there's two in particular that come to mind that are and not only two, but there's just two in particular that come to mind. One is the Smart Data Accelerator Interface, and that is the ability to use hardware to do data movement from one memory location to another memory location. And in and of itself, it is a very interesting approach to solving problems in um, especially in a highly abstracted area like something as a service. The other thing that's really important is computational storage, right? Where you've got the compute processing power next to the storage device itself. In and of itself, it is an interesting technology. Now let's switch over to UEC, for example. I've got a processor that needs to run an awful lot of data, and I need to move the data in, but the data has different types. It's got object types, it's got parallel file systems, it's got block, and not all are being used at any given point in time. But if I like in Lanel's situation, they managed to figure out a way to avoid having to move exabytes of data or at any given point in time for their iterative cycle inside of their workload by doing processing right at the drive itself. In UEC's terminology, we could do the same thing because the parallelism that involves really means that I've got to send data to another processor to be processed. But if I wind up with that same principle of having the compute next to the data, I now shut down the need for the bandwidth, the need for the latency, the need for the network connectivity at that level. I can actually reduce the need of it. You can't reduce it completely, you can't eliminate it, but you can reduce the need of it because these things are getting so big that you find yourself at the limits of physics. Right, we need better efficient ways of doing things. So what's that? That is the memory movement model, the processing near the the data itself, and you've got the proper network directly connected into the processors. One plus one equals three. So in and of itself, it's great. Combined to get it's even more powerful. Getting those two groups to come together and have those conversations has to start somewhere. And so that's what we did last month, and we're going to continue to do this in the future, not just with between UEC and SNIA, but organizations like OCP, like IEEE, UA Link, OFA, all of these different groups and organizations. That's just some of them. They all have a vested interest as we move forward in solving these massive problems to be able to be aligned. And fortunately, it's a really good thing right now, as of right now, there's a willingness and an inclination to do so.
It's interesting that you talk about that. If I had taken out all of the proper nouns from what you just said, you just described the edge AI use case as well, where we have limited bandwidth, we have to move processing closer to the data, et cetera. I mean, and this to me, Jay, this is the thing that has been so remarkable about going to industry standards bodies and events and seeing what they're developing. It's the maybe unintended, but always in fun and surprising cross pollination of ideas. I think when the next generation storage form factor designs were set, no one could have predicted how that would transform the design, the physical design of edge servers, and yet it did. And it is rapidly changing the entire edge industry. When technologies, DMA technologies and computational storage and so on. I think that those were defined before the AI use case arose, or at least the AI training use case arose. And yet, look at that. That's pretty useful over there, and that's something that makes this all happen. It's like it's like magic happens when you have different people with different areas of expertise all communicating openly and all saying, "Hey, wait a second, we did something really like this back in the day to solve this other problem. And now we have a similar problem here. What if we, for example, move compute closer to the collection and storage of data? What if we, offload things? What if we develop protocols that allow you um, to have, for example, hierarchical memory? That came from supercomputing, developing NUMA supercomputers. And then suddenly that's the core technology that enables CXL, or the core concept, at least, that enables CXL. It's so interesting to see how these things kind of spread like fire from one spot to the other spot. And I think we're definitely seeing that with HPC and AI right now, right?
Yeah. Yeah, there's a lot of characteristics of both that cross over, but enough of a difference to make it interesting. So yeah, it's one is not exactly a complete overlap of those Venn diagrams on the other, but there's, like I said, there's enough of a cross combination to really start to challenge people into solving those problems. I think when we get into what's going on in the future, the very cool parts of this is that much of what we want to do has been solved in the past. It's at a different scale, it's at a different level, but it involves, two basic fundamental concepts. One is the margin for error is much smaller, right? And as a result, very small increments of problems can create much larger amplification problems in for systems, right? Because of the tightly coupled nature of the way that these components work. If one goes down, the whole thing goes down. So it's very, very delicate, very sensitive. So creating robustness and reliability in there is something of a challenge. But the other part of it is time. And we tend to forget that as fast as we are still dependent upon other things to be able to feed us information, or we have to feed them information. And sometimes that information is at a higher level, it's at a control plane level, or it's at a management level, and sometimes it's the data plane itself. But the act of time has played a huge role in what we actually need to do, right? And that's where the bandwidth comes into play. That's where the latency comes into play. The ability to get something or send something very quickly also means that you now have to run the risk of being idle while these other things are doing their own thing, right? So the whole system has to rise. All the boats have to lift, right? That water has to be able to lift all boats. It's not good enough to say that I've got the world's best GPU or the world's best CPU or the world's fastest RAM if I can't get data in and out of it fast enough. Or if I can't get the other piece of the equipment on the other end of the wire to send or receive fast enough. And we're talking about wildly disparate components. We're talking about network interface cards, we're talking about, GPUs, we're talking about TPUs, and so on and so forth. And they're not all equal. They don't all have the same performance characteristics. And they're not designed to. So you've got a lot of variability and a lot of ambiguity when you start off with a very specific and demanding kind of workload, whether it be HPC or AI, that all has to work together in concert. You can't be playing, Bach's Fifth Symphony, Brandenburg's Concerto in one group, and then you have, Beethoven's Fifth on the other at the same time. It just doesn't work. Two beautiful pieces of music, just not at the same time. So you want to make sure that everything is working together in that concert. And that is where, you know, you have to think outside of your own myopic world And I don't mean that pejoratively. I mean that actually quite admirably, right? We work so closely on the stuff that we do that it's often easy to forget that what we do influences other people. And if you don't actually work with, they're going to go off and do their own thing. They're going to create yet another standard. They're going to create another way of doing things. And then someone's going to do something that's going to take off. And then all of a sudden, everybody's going to flock over to that. So if you want your systems to work and you want your approaches to work over time, you've got to rethink the significance and the influence of what you're working on in order to be able to make sure that not just you, but the people that rely on you are going to be able to accomplish this over time.
That's a very valid point, and I think it's interesting because everything you're talking about can be, to Steven's point, I can be right here in the core data center, and all those problems exist in one version of a world. And if I move out here to the edge, it all still exists, and then getting between the two becomes even more of a unique challenge. So it's always kind of crazy to see that. And your concept about the myopicness and things like that reminds me of going way back into past to a tape-based storage war. If for those that are old enough to remember, Betamax versus VHS, for example, that's a perfect example of kind of what we're trying to prevent here, both with SNIA, to Stephen's point about the broadcast of an evangelical side of things versus the nuts and bolts of being myopic and building the really cool thing, but the really cool thing lost because they weren't playing well in the marketplace, and the rest of the ecosystem didn't parlay along with them. So it's interesting to kind of always keep that in mind about past, present, future, and there's always going to be a fun new thing to work on. It's just where and how far away from today's shiny object of AI, or how far physically it is edge versus data center in this whole play of things that we're working on.
Great.
With that said, Jay, what are you most looking forward to? What developments in the industry are you looking forward to now that we have this monster business driver of AI? Where are we going?
I am most looking forward to, and this is more of a selfish me thing, I am looking more towards extrapolating the stuff that we are doing inside of these different things from a technical perspective and marrying them to the ethical and moral implications of accomplishing these goals. All right. I do think that we have a tendency as technical people to forget that what we do matters. And what I do is because of the fact that in order to preserve those guidelines, you should have the most efficient, effective, accurate data when you need it, where you need it, so that you can make informed decisions. And so I think the infrastructure is not divorced from those questions. It's not a software problem, it is an everything problem. And so I am looking forward most to being able to have those kinds of conversations where the work that we do have a full understanding up and down the stack, all the way to the end user, so that people can feel more comfortable with using the technology without having to fear some sort of AI, AGI moment of what's the word it's called? The anomaly?
Singularity?
The singularity. There you go. That's the word I was looking for. Um, and I honestly think that now is the time that we need to have those conversations, and I'm looking forward to having those.
Yep, and I'm gonna just go out on a limb and say, if you're interested in those conversations, they're happening in the standards bodies. They're happening where people can get outside of their companies and out there talking to each other. Again, I'll just put in a little plug. My favorite tech event is the SNIA Storage Developer Conference, because it is so open and nerdy and fun and engaging. There are, of course, lots of other ones. I mean, you mentioned OCP, which is always a lot of fun every single year. Supercomputing is always a lot of fun every year. There's a lot of great conferences out there. And anytime you get people together to share ideas openly and to really explore what this all means, what you're going to find is that people are not just technologists. They're not just trying to push the .1, .3 version of the specification. They're interested in having the big picture conversations that Jay just described. In fact, he and I have had big picture conversations with Scott, sitting in the lobby of the hotel at these conferences. This is what it's all about. So I urge our listeners to get involved in these things. Before we go, Jay, tell us a little bit. How can people get involved in some of the standards bodies and events that you go to?
Well, if you're interested in working on SNIA related material, the data related material, I encourage people to look at SNIA.org as a starting point. You can contact myself or Scott I don't, Scott is the chair of the communications steering committee for SNIA, and so he's responsible for communications. You can find me on LinkedIn, with J Metz. I am wearing a hat, or actually, am I wearing a hat? I think I'm wearing a hat inside my picture there. I may not be. I know, but what the heck? What am I thinking? The Ultra Ethernet organization, the website is ultraethernet.org, and there's a lot of material there under the news situation. As of right now, we are just on the precipice of finishing up the 1.0 specification. We're going to have a lot of material educating people on what that means, how it works, how to implement it, and so there's a lot of material in both organizations that are coming down the road in the next 6 months or so that you can find out a great deal of information on these topics.
How about yourself, Scott? What's coming up for you?
Yeah, so it was great to do the field day. We had the SNIA event, so we have some future events coming up as well as planning for SDC. And if you're looking to kind of connect with myself, as Jay mentioned, you can find me through SNIA as well as I'm on former Twitter as SM Shadley and Blue Sky at SM Shadley as well as LinkedIn. Feel free to drop a line and we'd be happy to talk.
Thank you very much. And as for me, you'll find me at sfoskett on most social media networks, including the X Twitter, as well as the Blue Sky and the Mastodon. And I would love to find y'all there. You, of course, can find me as well on the Utilizing Tech podcast, the Tech Field Day podcast, Tech Strong Gang every Tuesday, and the Tech Field Day rundown some Wednesdays when I don't relinquish the chair to my friends Tom and Al. So thank you very much for listening to this episode of Utilizing Tech. You can find this podcast in your favorite podcast applications. Just look for the words Utilizing Tech, as well as on YouTube as a video if you want to see what we look like. You want to see Jay's hat. If you enjoyed this discussion, please do give us a rating or a review. We would love to hear from you. This podcast was brought to you by Solidigm, as well as Tech Field Day, part of the Futurum Group. For show notes and more episodes, head over to our dedicated website, which is, not surprisingly, utilizingtech.com, or find the show on X, Twitter, Blue Sky, and Mastodon at Utilizing Tech. Thanks for listening, and we will catch you next week.